Today's title, the derivative and tangent line equations. So being able to write the equation of tangent lines, such as this red line that we have here in this graphic, is really one of the first really major concepts of calculus. And today we want to kind of integrate the idea of finding the value of the derivative and the role that that plays in writing these tangent line equations. So we're just kind of playing around with this fake, unknown curve, and we picked a point on the curve. We gave it a name. We're going to call it P. And then what we did is we drew a really nice tangent line at point P. And so we drew this really nice line. And I think some of these graphics are so important to have in our notebooks that kind of give meaning to some of these goofier problems that are hard to visualize. So what we have right here, let's pretend, let's see if I can find black. How do I, there we go. Let's see, do I have, there it is. All right, we're back in business. So let's say we have this curve here and let's name it f of x, right? So, and again, this is point P. So instead of saying x equals 1 or x equals 3, we're just calling it P. So if I said f of P, that would represent the y coordinate at that particular point. But if I said f prime of P, that would represent the instantaneous slope or the derivative at point P. Now, what's curious, and I didn't mention this in an earlier video, and I was kind of kicking myself, like for any random function here, there's an infinite number of points along that curve, right? We've got a point here, 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 a point here. And then you consider all the million, zillion points in between those ones. We have an infinite number of points. Technically, on this curve, every one of those points has its own unique slope. So the derivative changes from point to point. There's a million infinite different derivative values. Now, one of the things that we're going to do in today's lesson is we're going to give you the point of tangency, okay? That's the point where the tangent line actually intersects and skims the function, right? We call that the point of tangency right there. So there's a nice hot buzz phrase. And we're also going to give you one other point that tangent line passes through. So maybe we'll give you this point right here. And we'll say, okay, using those 2 points, can you find the slope between those 2 points, right? Easy peasy. Well, the slope between this point and this point is equivalent to the derivative of f at point P. So finding the slope from this point to this point is like finding the derivative at P. Let's go dive into one. Again, some of these are very hard to visualize. So we have a tangent line, and it's tangent to the graph of f at the point -3, 4. And that tangent line then goes on to pass through the point 7, 9. So I don't know if I dare draw this. Let's give it an attempt, right? So -1, 2, 3, 1, 2, 3, 4. Okay, so here is the point of tangency, right? And sometimes I call that the POT, the point of tangency. And then the tangent line also passes through 7, 9, 3, 4, 5, 6, 7. There's 7. 5, 6, 7, 8, 9. So we're up in this neighborhood here. So let's say here is my tangent line. That's super hot. Now, what might function f look like? Well, we have a lot of degrees of freedom here. It would almost be a turning point. There we go. So here's one possible sketch of what f looks like. I just knew that at that point right there, f had to be slightly increasing. So he was probably approaching a turning point, like a relative max, and so forth. But anyway, so what we really want to do is find the slope of that red line, because if we can find the slope of the red line, then we just found the value of the derivative of f at x equals -3. So all I'm going to do is I'm going to do 7 minus 4. That's your rise. I'm going to do, oh my garage, why am I using 7? I'm sorry. That should be 9 minus 4. And then on the bottom, we'll do 7 minus -3. That's your run. So we've got 5 over 10. That's 1/2. And so all we're saying is that the derivative of f at -3 is equal to 1/2. Bada bing, bada boom. Okay. Whoa, that got crazy. We'll call that. Let's try this. Can we slide? Can we slide? Okay. So we have this mysterious function f. We don't have a picture of f. We don't have an equation for f. But what we do have, they did tell us that f of 2 equals -5. So let's just stop right there. Let's dissect this little nugget of information. When they say that f of 2 is equal to -5, what they're saying is that 2 is the x-coordinate and -5 is the y-coordinate, right? And together, that makes up your POT, your point of tangency. Now, the other nugget they gave you was that f prime of 2 equals 2/3. What are they trying to tell you there? So when they say f prime of 2 equals 2/3, they're not giving you another y-coordinate. What they're saying is that at the particular moment when x equals 2, the slope is equal to 2/3. So here's what you got. You got all the key ingredients. You've got the x-coordinate of 2, and they're saying at that moment, the corresponding y-coordinate is 5, and the corresponding slope is 2/3. So everything's like really married together here. Let's see. What do they want you to do with that information? They want you to write the equation of the line tangent to f at x equals 2. Well, as soon as they invite me to write the equation, here's what I'm thinking. Here's what I write down on my paper every time. Y minus y1 equals m quantity x minus x1. Bingo. Now, if you want to make some notes to yourselves, we could say this. This rascal right here is a variable. This rascal right here is a variable. We are not substituting any numbers for those two variables right there. But this little rascal right here is a constant. This is a constant. This is a constant. Okay, we are going to substitute numbers for those spots. All right, this is going to be a, whoops, let's switch to the pen here. This y-coordinate is going to be a 5. The slope is going to be 2/3, and that x-coordinate is going to be a 2. So all I'm going to write here is that y minus 5 equals 2/3 quantity x minus 2, and you've got the equation of your tangent line. Now, don't shoot me if I'm wrong here, but I think that's as far as you have to go on the homework. Now, I believe it's going to be a multiple choice question, so you'll be able to tell readily, very quickly, how far you have to take this. Now, there is the potential at some point that they may have you distribute the 2/3 and then add this 5 to the other side so that you effectively isolate the y, but I don't think you're going to have to do that tonight. And I know going into next year, we very, very rarely have to clean these up, which is awesome.